audible? Hello. Okay. Hi, I'm Shruti and I'm one of the TAs for the course. Can you guys introduce yourself? Sagnik, where are you from?
Hello, ma'am. I am from West Bengal, Kolkata.
Okay. You are a bachelor student, master student?
I am doing masters.
Masters. Okay. First year?
And no, ma'am, second year.
Okay. And Dinesh, what about you? Okay. So Dinesh is not replying. So let us start. Actually, what I'll do in this tutorial sessions is I will be solving the assignment questions, but I'm not allowed to solve the assignment like until the submission date is over. Okay, so now I will be solving like week 0 assignment, which is not graded. Okay, so we are studying here symmetry and group theory. So can any one of you tell why is it important to study symmetry and why symmetry has been related to group theory? Sagnik?
Through the group theory, we can describe the symmetry.
Okay, yes. But why do you need to study symmetry?
Uh, to know the molecular reaction and how does they work when the symmetry or asymmetry.
Okay, yes. So when we know the symmetry of a molecule, we can define the energy levels. We can know that which orientation will have what energy like that, and how the reaction will go, how the bond formation will happen. So like symmetry or unlike symmetry. So like these things are answered by symmetry. So that's why it's important to study it. And group theory is a tool to study the symmetry. So symmetry means like what? Geometrical orientation or configuration of the molecule. But it's not always feasible, right, to draw the bonds or the orientations all the time. So what we do is we take this mathematical tool, which is the group theory. Group theory is a mathematical uh, theory, right? Sets and group theory you guys might have studied in maths. So that we use to describe the symmetry of the molecule in the mathematical representation. So that's why it's the course name is symmetry and group theory. So we have to study the symmetry of the molecule by using the group theory. Okay.
Okay.
So how many lectures have you watched till now?
My exams are end in this week, so I have not watched. I think.
Okay. Okay, so let us start. What we will study in this course will be So first thing will be, so today will be very introductory lecture. I am not gonna cover much today because it's like I have to solve the initial week 0 non-graded assignment only. So I'll be giving just overview today, and what is a group, how do we form a group, what is a point group, and then we'll move to that assignment questions. Okay, so what we are gonna learn. First thing is First thing is what I said, symmetry. Okay, so what in the symmetry will be the classification of molecules into different symmetry point groups. Okay, so to define symmetry, how do we say that which molecule is of what symmetry? We have to give names to some kind particular kind of symmetry, right? Suppose we have shapes, so we have different kinds of shapes, like rectangle, triangle, circle. So a given object of that kind of geometry is called a circular object or rectangular object, like that. So the molecules can also have different type of shapes, like orientation in the 3D space. So what molecule belongs to what kind of geometry is decided by its point group. So we have to classify the molecules according to the number of symmetry elements they possess into different point groups. Now, next thing what we will learn will be matrices. As I said, that we are trying to study the symmetry using group theory, which is a mathematical thing, and we need something to represent the symmetry. Suppose you represent the chemical formula of a molecule, right, using alphabets, or like suppose CH2 double bond CH2, like that. So you use these symbols to represent its chemical formula. So likewise, how do we represent symmetry? We represent symmetry through point groups, and we represent point groups through matrices. So it is, so matrix will take us to, so symmetry is geometry and matrix is algebra. So we have to convert this language of geometry to the language of algebra. That's the course is about, symmetry and point group. Because as I said, we cannot keep on drawing geometries all the time. It is very tedious, right? We have to have a systematic method, like systematic method to translate the geometrical information of a molecule. So this method is your group theory. Okay. Next thing which we will study is in this course will be, I'm just writing a few points which this course covers. Okay, which are representations. If you are new to this course, then don't worry about these terms now. We will cover these things like in coming weeks. So I'm just writing the topics which we are going to cover. Then, okay, then we will have, of course, character tables. Okay, so these are the topics which we are going to cover. First, we will come to the uh, point groups and the classification of point groups. Then we'll move to representations, reducible, irreducible representation, and then there is a great theorem called great orthogonality theorem, GOT in short. And this theorem will help us. There are many applications which we can cover through this theorem. Then character table. Now character table is something which tells that how the molecule will behave. Sorry, I lost connection. Okay. There are few books which you can follow for this course, and also not specially for this course, anything which, like, you guys are master student or bachelor student, you can follow this course for your own degree exams. FA Cotton. Why is it not visible? Can you guys see anything which I'm writing?
The screen is visible.
Can you read what I'm writing?
Yes, ma'am.
Okay, fine. I cannot see what I'm writing. That's why. Sorry. Okay. Next one is, okay, you can find these books online, and if you're not getting them, you can just tell me in the next session, or you can write to me. I'll put it in the drive folder. So, first let us start. What are the basic symmetry operations? Okay, can anyone tell me what is the difference between symmetry element and symmetry operation? Now, what's your name? How do you pronounce your name?
Naufa, ma'am. Naufa.
Naufa. Very nice. Symmetry element. She is saying that symmetry element is the geometric entity which we apply to bring about the symmetry operations. Right? So, symmetry operation. So, it's what she says is correct. So, the geometrical entity with respect to which the symmetry operation is performed. Then what a symmetry operation is? So symmetry operation is something when applied to a system applied to a system, or you can say a molecule or group of molecules that leaves that molecule in the same configuration, in equivalent configuration. So there is another term. So this term is important, equivalent configuration. So how do you decide whether a configuration is equivalent or not? How do you decide whether something is equivalent or not? So equivalent means the position of the atoms. Yes, the position of the atoms should not change. Yes, you guys are right. There is no change in the position of the atoms, and both the structures completely superimpose each other. Okay. Now, as I told, there are two things: symmetry element and symmetry operation. So first, look how many symmetry elements are there and what are their operation. First one is symmetry plane. What does a plane do? A plane reflects, and its symbol is, so we denote the plane as sigma, Greek letter sigma. Another will be inversion center. So as the name suggests, it inverts. So what happens? So every point which is x, y, or z gets translated to minus x, minus y, minus z. And inversion center is denoted by I. Next is proper axis. What does an axis do? Around that axis, the object or the molecule has to rotate. So it brings about rotation. Rotation by how much is decided by about 360 degree divided by n. 360 divided by n degrees. What is n here? It is represented as Cn. Okay, so suppose if n is 1, the rotation should be degree should be 360, which means no rotation. If n is equals to 2, it should be 180. N is 3, it should be 120. Likewise, the fourth one is improper axis. So improper axis, it is denoted by Sn, and it is a combination of two operations. First one is rotation by 360 by n degree followed by reflection through a plane which is perpendicular to the rotation axis. Okay, so if rotation axis is Cx, suppose Cx2, then the plane has to be YZ. Okay, it has to be perpendicular. So this is improper axis. And there is one more symmetry operation which is known as identity, and it is denoted by E. So identity is what? It does nothing to the molecule, no change. You can think of identity as an rotation by 0 degrees or a rotation by 360 degrees. It does not bring any change to the molecule. Okay, so why do you think that this type of symmetry operation exists when it doesn't bring any change to the molecule? Dinesh, can you think of it? Now for okay, so in the beginning what I told, okay, let me discuss this first, it will be clear then. So have you solved week 0 assignment? Okay, so there is a question in the assignment week 0. So it says that the property that is not necessarily required for a group: closure, commutativity, associativity, identity element. Okay, so in the beginning I told that we are trying to study the symmetry using the mathematical tool which is the group theory. So the group has to follow some properties. So this group theory comes from the set theory. Okay, now a mathematical group, something is called a mathematical group when it follows certain properties. The properties are closure, associativity, existence of identity, existence of inverse. So if a group follows all this property, then only it is said to then only it is called a mathematical group. Otherwise, that is just a set, not a group. Okay. So how we denote a mathematical group is like this. Suppose we have a group of some elements A, B, C, D, likewise, and this is the set of elements and it has to have a operation. On this operation has to be applied on these elements. Okay. So this operation is called binary operation. This is how we represent a group. Now, the first property which I said is closure. So, what is closure? These things are needed for the our symmetry course also. That's why I'm telling. So, closure means suppose you have two elements A and B which belong to the group G. Okay, the G group is same as this group A, B, C, D. Likewise, and star is the binary operation for this group. So suppose this A and B elements belong to the group G, then if I operate this binary operation star on A and B, the resultant element should also belong to the group G. Okay. So A star B is the resultant element which we get after applying this binary operation star on the elements A and B. This resultant element has to be a part of the group. Okay. So now let me give a real example. Suppose G is a group of natural numbers. Okay, and the binary operation which I am talking about star was some random operation, anything I represented as star. Now in particular, if I take addition is a binary operation, right? So, and what are natural numbers? Natural numbers start from 0 onwards, right? Is it correct? Yeah. So it starts from 1, 2, 3 onwards. Okay. So when I take natural number and uh, I take this operation addition. So what happens? Suppose 1, 2, 3, 4, 5, and my operation is plus. So if I operate 1 and 2 using this binary operation which is plus, what is my result? Result will be 3, and 3 already exists in this natural number set, right? If I do 3 plus 5, what I get is 8, and 8 already exists in the set of natural numbers. So you can take any example. 50 plus 10 60. This is already an element of natural number. So this group of natural numbers n under operation plus is said to follow closure property. Okay. So you understood what a closure is? Does every group will follow closure? Suppose again we take the set of natural numbers, and instead of addition you take subtraction or division as the binary operation. So if you do 2 minus 3, what should be the answer? -1. Does this belong to natural number? No, right? So the same set of natural number which was following closure with addition is now not following the closure property with subtraction or division. Suppose if you do 2 divided by 3, the result is not there in the set of natural number. So this set does not follow the property of closure. So natural number with subtraction as the binary operation can never form a group. Okay, because there were four basic criteria to form a group: closure, associativity, identity, and inverse. So if the set of natural number, all of them has to be there, has to be exist. If any one of it is not there, then the set will not form a group with that particular binary operation. Okay, so let's move to the next property, which is called associativity. Now what it means is, now we have a group A, B, C likewise with an operation star. Okay, then the order of the operation should not change my result, should not change the answer. Okay, so suppose if I do A star B first, and then whatever the result comes, that I operate with C. This result should be equal to if I do B star C first and then I do this operation on A. Okay, this means that the order of operation should not change the result. Right? Suppose if A star B is X, then A star B star C will be what? X star C. And if, for example, this result is 10, then the reverse one, A star B star C, should be equal to A star, and suppose if B star C is Y, then this will become A star Y, and this has to be equal to 10. If it is not equal to 10, the group is not associative. Again, you take the example of natural numbers with subtraction or division. It will not be associative. But if you take the example of multiplication or addition, it will be associative. Sorry, not multiplication. Multiplication, yes, multiplication will also be there, because if you do 5 into 2 into 2, or else if you do 5 into 2 into 2, then whatever the result are, both are equal. So the group is said to follow associativity. The next third property is existence of identity. Now to explain this, I explained you the other two. Existence of identity. This is the third property. It says that the group should have an identity element which, when operated to any element of the group, results the same element. Should have an identity element E operated on okay. Suppose let us take the set of integers under the operation addition. Okay, so there exists this identity element. In this case, that identity element E is 0. So whenever you do any element A plus E, because this operation is here, the operation is plus, what you get is A again. So you do minus, so you do anything, 5 plus 0, you get 5. You do minus 20 plus 0, you get minus 20. So the operation with the identity element does not change the element. Understood? So whatever we operate with 0 does not change that element. It regenerates that element. So why did I take this example of integers here instead of natural number? So you realize natural number with plus, there is no identity element. Does not exist. 0 doesn't exist in the set of natural numbers. Okay. So the least element here is 1, but if you do 1 plus 2, it 2 will be changed to 3. So 1 cannot be identity element here. Now can you tell, is it always necessary to for an identity element to be equal to 0? No, right? So this identity element depends on the set we are taking and the binary operation we are taking. If we are taking the set of natural numbers and the operation is multiplication, then here the identity element is 1. It's not 0, because if we multiply anything with 0, first of all, the natural number will not follow closure. Suppose I have this natural number 5, and if I multiply it with 0, the resultant will be 0. But then this is not an element of the group, does not follow closure. Closure is not followed. So rule 1 is broken here. Next thing is, when I operated 0 on 5, the 5, the resultant got changed. The resultant is not 5 here. So the existence of identity is not there. So the set of natural number with multiplication is not a group, because it is violating two rules of being a group. Okay. So when I was telling why it is important to have an identity here, now can you guess that to form a group, so we have all these elements: symmetry, plane, inversion, center, proper axis, improper axis. But if the identity element is not there in that set, then it cannot form a group. So it does not change anything to the molecule or the system, but it is always there with a molecule, because a molecule will always have an identity element. No matter if it doesn't contain any symmetry element, it will contain identity. Okay, so this was it. Identity was needed for the mathematical completion of the definition of group. Now, just for the sake of completion, there is in the fourth property which I told is existence of inverse. Now, this inverse is there as as inversion center. Now, what the inverse do? What it what this rule of group theory says, that in the group there should be an element which, operated on any other element, generates the identity. So let us denote this inverse as A inverse. Okay, so A inverse is an inverse element of A. So when A is operated with its inverse, it generates the identity element. E is the identity element. Understood? Again, take that example of integer set under addition. So suppose you have this addition operation and you take this element minus 3 which belongs to the set of integer. Now what you have to put here so that you get the identity element of the set. What is the identity element of the set? Identity element of this set was 0. This is the identity element. So identity element 0. So what you have to add here to get the identity element? 3, right? So does 3 belong to this set? Yes, of course it belongs. So this is a valid input which you can give here. So now you can call it that for minus 3, 3 is its inverse, or vice versa, for 3 minus 3 is the inverse. So when these two are operated on one another, it generates the identity element. So this is the rule for this property, that the inverse of the element should exist within the group itself. You cannot keep anything which is outside the group. So suppose outside the group is 3.3. You cannot use a decimal number here because first of all it doesn't belong to the group, closure is not followed, and it will not generate the identity element. So these were the 4 rules. If any set with a particular binary operation follows all these rules, it is said to form a group. Okay. So, so the question in the assignment was, the property that is not necessarily required for a group is, of course, closure is required, associativity is required, identity element is required. So the property that is not required is commutativity. What do you mean by commutativity? Commutativity means that A star B is equal to B star A. Means when you reverse the order of the elements, the operation remains same. That is commutativity. But this is not a criteria for a group to exist. Associativity and commutativity are different. Associativity talks about the way the operation, the order of the operation, and commutativity talks about the order of elements. Okay, so let us come to these questions. What I was talking about, identity, so these are the 5 symmetry elements, and these are the operations that they do. Now let us try to solve these two questions. Let's solve this first. The product of the following matrix multiplication. I'm sure all of you know matrix multiplication. What is the answer here? How the matrix get multiplied? Suppose the order of one matrix is n cross m and the other one is p cross q. Can I multiply them? What is the criteria for the multiplication to take place? So this is row, this is column. So m is column number of the first matrix, p is the row number of the second matrix. So m should be equal to p. Number of columns in the first matrix should be equal to number of rows in the second matrix. So here you have this matrix 3, 2, 5, 8. So the first one is 2 cross 2. It has 2 rows and 2 columns. The second one is 2 cross 1. So we represent number of rows first and then number of column. So this is row, which is this, and this is column, number of column, which is this, that it has only one column in this direction. So now you see that these two are equal. So the resultant matrix will have 2 cross 1 order, which means it will have 2 row and 1 column. So you can simply neglect these two options because they have 2 rows, 2 columns. The possibility is either this or this. Now how you do multiplication is, suppose this is 3, 2, 5, 8, 4 and 6. So row and then column. Then this will get multiplied with this. So this is like 3 cross 4, 3 into 4, then plus 2 into 6. Next time, next will be 4 into this, 5 into 4, then 8 into 6. Second row, first column, first row, first column. So the answer here will be 5 into 4 plus 8 into 6. Now you do the maths. So this is the answer. Third one. The combination which have the same group and subgroup. Now today I have just talked about group. A group can have a smaller group within it, which is subgroup. So I'll talk about it later. So let's just leave this question as of now because we have to talk about point groups first. So let us talk about first how to classify the groups. Sorry, how to classify symmetry point group. Now if I talk about group, it means point group, symmetry point group. So if the group, first of all, if you see a molecule and if you find it is of very low symmetry, so it is of very low symmetry, then it can be it can have point group C1, CS, Ci. Okay. If not, no, then here you write yes. Then if it is not of low symmetry, it will be group of very high symmetry. Then it can be of point group like this: tetrahedral, octahedral, icosahedral, C infinity V, D infinity H. Okay. If it is not that as well, then you look for highest order rotational axis. So the rotational axis was denoted by C, right? So if you look for the highest order of it. Order means if a molecule has C2, C3 and C4, all of them, then the highest order will be of C4. Then if I'm continuing in the next page, then look for Cn, whether it is Cn, whether it is now you found C4 is present. Out of C2, C3, C4, C4 is the highest order. Now C4 you have got. Now look for perpendicular C2 axis. If there is any perpendicular C2 present, perpendicular to the C4, because C4 was the highest order. If perpendicular C2 is present, then it belongs to D group. Okay. If it is not present, so perpendicular C2 is not present, then it belongs to C or S group. Okay. Further, there is classification in D group. Look if sigma H is called molecular plane. If sigma H is present, okay, if sigma H is present, the point group is DNH. N will come from here, the highest rotational axis, so DNH. And if sigma H, which is the molecular plane, it is not present, then look for sigma D, which is the dihedral plane. If that is present, then it is DND point group, and if that is not present, then it is simply DN. Okay. Similarly, here, if you have found that the highest rotational axis we found C4, but there is no perpendicular C2 axis to it, then we will look for, then it belongs to point groups either C or S. Then we will again look for sigma H, molecular plane, sigma H. If sigma H is present, then it is CNH point group. If it is not present, then look for sigma V again. Then it will be called CNV point group. And if sigma V is also not present, then look for S to N. And if this is present, then it is S to N point group, and if this is not present, it is CN point group. So the point groups are here, 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 and here. And these are the point groups. So any molecule will belong to any one of these. Is it clear? Okay. Now let us solve this question. For the following molecule, symmetry elements that are not present. So the molecule is like this. Now it is asking for the symmetry elements which are not present. So check for point of inversion. Also, I forgot to tell you, the point of inversion is a point through which we interchange the elements to minus x minus y minus z if the present coordinate is xyz. And this point of inversion can lie anywhere on the molecule, like on an atom or in a space or on a bond, anywhere. Suppose this is a molecule like this, something planar molecule. The point of inversion here lies over here on this bond. Okay, but if a molecule is like this, the point of inversion in this case lies here in between. Okay, so it can lie anywhere. Now for this molecule, do you think that the point of inversion is there? So if I invert this, suppose I say the point of inversion lies here. If I invert this, this will go here, this will go up, but then it will not be the same molecule. So it doesn't lie over here. Then if I check it on this bond here, does it invert? No, it doesn't have to change only these two atoms. It has to change all the atoms. So here is that center. Here you have, here also you have HH. So if I invert through this point on the bond, this H has to find another H somewhere here. But there is no such atom here. Okay. So this 2 will get inverted. But what about these? So the inversion does not exist. Next, check for C2 excess. Okay, this is the molecule. Then if I put this C2 excess like this is C2X. So it will rotate it like this. So what will happen? This will go up, this will come down. Out of plane rotation. Okay, so it will be like out of plane rotation. So if you have, suppose the top side is, I'm putting it in green color, and the bottom side, there is no such top and bottom side. I'm just showing it for imagination. Okay, then this is XA, this is XB. Both are X. I'm just naming them. Then when you apply a C2 like this, C2X, what happens is it flips and the red one comes on the top and the green goes in the bottom. Okay, it's like flipping like this. So here it will be XA will be in down and XB will be on top. But this is identical configuration, equivalent configuration, because these two X are not distinguishable. When I superimpose this configuration over this one, it is superimposable. So this is a valid symmetry operation. So the C2 exists for this, C2X exists for this molecule. Now similarly, can you check for C2Y and C2Z? Dinesh, are you there? So how do you check for, let us check for C2 so C2Z has to be like this. So it will be flipped. So this X will come here. This will go down and this will come up. Yes, there is no C2Z. And if you do for C2Y, how will it change? Let me write it as XA, XB, C2Y. Oh, sorry, here I did C2Y. So it has to rotate along the Y direction. So where will XA go? XB will become up and XA will become down. And C2Z will also give the same. But this time this has to flip like this. And this has to flip like this. Okay, so this will be just like this. This will come over here. X. If this is A, this is B, this is XA, and this will be XB. Is this correct? Oh, sorry, XB, not two bonds. XB. Now, is this correct? Okay. So now here we see is that the configuration has been changed. So only C2X is present. C2Y and C2Z is not present. Now next one was C4 axis of symmetry. how will you do C4 axis? Again put it as XA, XB, and your axis C4. Let us try C4Z. So it goes in the mid. So it is like this. So C4 means rotation by 90 degree. So it has to go like this and this has to go come here, right? So it will form XA will come here and XB will go there. Okay, if you can name them 1, 2, 3, 4, then what you say that XA which is attached to C1 will be here. This is 2, this is 3, this is 4. So yes, you are correct. It is not present. You can similarly check for X and Y. C4 is not present. Then what it asks for mirror plane. Mirror plane. Okay. Now look for mirror plane. Does it have mirror plane? Not present. So let us first put planes. So if this is X, this is Y, this is C. So if I put a plane like this, sigma YZ. Let me do two more. Then sigma XY. So the plane is parallel to this molecular plane. Then one more will be sigma. It will be like this. Okay. So what happens? A plane reflects. Okay. So after reflection, this will get changed as this will come over here and XB will go over there. Then here what will happen? So this plane will reflect, so XA will become down and XB will become up. And here it has to reflect like that, so here XA will be up and here XB will be down. But the configuration is changed. So no sigma, no plane is present. Okay, so what are not present is mirror, C4 and point of inversion. C2 is present. Is it fine? Now you do this question. For an H2O2 molecule, both cisplanar and transplanar conformation. You solve this, I'll take a break. हेलो रूम पे NPTEL वीडियो हाँ 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 बाद में करती हूँ 10 मिनट बाद Is it solved? What is the answer for this, Nafa? Okay, okay, okay. Do it. I'll tell you the answer for this one is this. You try to find out, try to solve it. Okay, fine. Okay, so you have solved anyway. You have solved the assignment 0. You can submit it on NPTL. Yeah, because that is anyway non-graded. You should submit it. If you are taking the course, you should submit the assignments. Okay. So do you have any other doubt as of now? Okay. So I will close this session now, and next week we will discuss assignment 1 and the related topics. Okay. Thank you for joining.